crude oil because it is also one of the hydrocarbon. What is crude oil? No idea? Okay. Where do you live? You live at a place where you have lots of oil. Okay. So the oil that we take out in a raw form from the earth's surface, that is called as crude oil. Okay? So that is then going to be, you could say, filtered. Filtered mean processed. Now the whole process is known as fractional distillation. So we are going to learn about the fractional distillation now. Okay, let me define fractional distillation first. So fractional distillation is a process in which a substance is, or you can say a mixture or the fractions of mixture are separated on the basis of boiling points. Okay, we discussed earlier while we discussed the characteristics of homologous series that that the hydrocarbon with higher carbon number would have higher melting point or boiling point, and the hydrocarbon which has lower carbon number would have low melting and boiling point. So let's say we have a kerosene and then we have the diesel. There are less number of carbons in kerosene oil, but there are more carbon number in diesel oil. Okay, so kerosene would have a lesser boiling point as compared to diesel. Okay, do you know what is diesel and what is kerosene? Okay, or shall I use the word paraffin? Okay, no, it would be difficult. Petrol. Okay, the petrol and diesel, these are two different types of crude oil. So crude oil is separated. Crude oil is a mixture. It has many substances in it. It can have jet oil, it can have the diesel, it can have kerosene, it can have the naphtha, it can have a different fractions. So we have to separate the fractions from the crude oil, and it's an expensive process where we need to do the distillation. So fractional distillation means the separation of substances on the basis of boiling point. Let me show you. Oh, okay. Let's do this. Let's copy this. I guess this image is quite clear. Okay. So we heat the crude oil. Okay. And then we have different chambers. So the substance that has the lowest, let's have the lowest boiling point is going to be, oh, boiling point is going to be separated first, because you started from zero. Once the temperature reached to 25 degree, the petroleum gas is going to be separated. Okay, I'll explain the whole process of distillation later. I'm just explaining that this is how we done. When the temperature reaches 60, all the petrol gets separated. Okay, so each fraction has its own boiling point. So we are separating the fractions or the components of crude oil on the basis of boiling points. Okay, okay, now what is distillation? Let's have a good understanding of distillation. Okay, distillation is a simple process that we commonly use in labs in our chemistry. Okay, do you drink mineral water, right? You use mineral water. Mineral water is produced by distillation. Okay, I'm giving an example of mineral water. Let me first tell you what is mineral water. Okay, what we do, we take the salty water, okay, and heat it or boil it. Okay, once it is boiled, only water vapors are going to be evaporated, not salt. Salt is not going to be evaporated. Only water vapors are going to be evaporated. These water vapors are then condensed back into liquid. Okay? And now that liquid would be known as distilled water. So what happened? Why every mineral water company has a different taste? Now this distilled water we add a mixture of minerals. Now every company, whatever company is producing mineral water, is going to add minerals according to their policy. Whatever is their formula, they put minerals according to that. And this is one reason why mineral water tastes different for each company. Okay? So this is a general process. We convert them into vapors and these vapors are then condensed. So we vaporize it and then we condense it. Vaporize, condensed, vaporize, condensed. This is distillation, a simple distillation. And because it's a mixture, so we called it a fractional distillation. If it's one compound or two compound, we call it simple distillation. But if there are many components, then it would be known as fractional distillation. Okay. So about the fractional distillation, I guess we have done the crude oil part. Um, just give me. Let me check if I need to add something else as well, because according to me, this is all in fractional distillation. Okay. There is a whole process given that crude oil is heated and vaporizes. The vapor of hydrocarbons enter the column which has a temperature gradient. The vapor are then condensed at the bottom of the column and these are then again the temperature boiling point rises up and then to the next column and they condense at the top. This is all written for this one. So I guess we have discussed everything. Okay. So these all are basically the fuels. So when we burn the hydrocarbons, what would be our product? Carbon dioxide and water. That would be same in each case. Whether it's diesel, whether it's petrol, whether it's paraffin, naphtha, whatever. Okay? That would always result in carbon dioxide and water. So we have already have discussed the complete combustion and incomplete combustion. Okay. Now these are not only hydrocarbons, fuels also contain, because we are getting it from these are the fossil fuels. Fossil fuels also contain the sulfur and nitrogen, because our body contains sulfur and nitrogen, right? So fossil fuel is formed by the animals and plants. So they contain the nitrogen compounds and sulfur compounds. So when we burn it, they produces the oxides of sulfur or oxides of nitrogen, which can lead to the pollution. Okay. So whenever we need to filter the crude oil, we just replace we remove these nitrogen and sulfur compounds as well to make it more filtered in a filtered form or in a good form. Okay. Next thing. Uh, since you are a girl, so I'm not expecting this answer from you. But let me ask: do you know the difference between the um, what do we call it? High octane and the other petrol? There is one category which is known as high octane. No. Okay. So since these one are longer chains, so when we burn them, because these are the crude oil products or oil, they have different carbon number. Okay. When they have different carbon numbers, they are going to they can cause hindrance while burning and this would be known as cracking. Let me wait. Okay, if you use a low quality petrol, your car can produce a very knocking sound. It won't be smooth. It would give you a very knocking sound. Knocking means it can like it would stop in the middle. It won't give you like a good drive. That is knocking. Okay, so the high quality petrol, it is actually converted into smaller chains, and smaller chains can easily burn as compared to the longer chains. So we convert, sorry, sorry, the longer chain fuel into the smaller chains in order to get a better quality when these fuels are burned. Okay, and this is known as cracking. Oh, where is it? Cracking. Bigger chains into smaller chains. And we prefer a smaller chain of 8 carbons. That's why the petrol is known as high octane. Okay? Let me find one question according to this one, the octane one, and then we'll do the cracking part as well. Okay. Okay, I found a question. So cracking is the conversion of bigger chains into the smaller chains. Okay, there are two methods to this, and the very common one is the catalytic converter. Why do we use catalyst? To speed up the reaction. Good. Since it requires a lot of heat, so we use catalyst to reduce the cost of heating to that much extent. Okay. So first of all, in the presence of catalyst even, we have to give a temperature of around 600 to 700 degrees Celsius. We vaporize it, and we know that when we heat it, the chains are going to break down. Heat would break the covalent bonds of these hydrocarbons and convert them into shorter chains. These shorter chains may have the single bond or may have a double bond. Let's say saturated or unsaturated. I'm giving you one reaction. Let's make a 10 carbon compound because we need to convert it into octane. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm just writing this form, okay? I'm not making the complete form. CH2, 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 and CH3. Okay? When we provide it with a temperature of 600 to 700 degrees Celsius in the presence of a catalyst, it is going to break. So there would be formation of an 8 carbon chain, C8H10. Okay? This is, well, let me write C10H. Oh, sorry. I have to write 18 over here. C10H22, I guess. Yes, it's an alkane. So what is left? C2H4. So what would be structure of C2H4? This. So it would have a double bond. So there would be formation of saturated hydrocarbon and there would be formation of unsaturated hydrocarbons. Okay, this is the only reaction that is going to be part of your syllabus, or maybe there would be more number of carbons, then you have to add a double bond in some of them. Okay, then there is one topic given which is not related to you, that what is supply and demand of crude oil. So yes, the demand is really high and the supply is really low nowadays. And it's different for different products. We need more diesel as compared to bitumen. So we need more petrol now. We need uh, lesser bitumen now, because okay, bitumen is basically used to pave the roads. We put it on roads to pave it. So we are also converting the trash into the material to pave our roads. So that's why the demand of bitumen is decreasing nowadays. Okay, while if we talk about petrol, we need a petrol. We need to run our vehicles, we need to run our different industries. So yes, we need the fuel. So the demand of fuel is always high, whatever fuel is high, whether it's naphtha, jet fuel, or whatever. We need it in higher quantity. Okay, so there is a question related to it. Let me just put the question. Where is it? The petrol one. Okay. Then we have to discuss the effects of oxide at the end, the last topic for today. Okay. The production of polymers from crude oil involves several processes, which is fractional distillation, cracking, purification, and polymerization. Now, polymerization is the last part. We are not going to discuss it for now. But we have discussed fractional distillation, we have discussed cracking, and we have discussed the purification. Okay, three of the fractions obtained from fractional distillation are fuel oil, gasoline, and kerosene. Which fraction would you think have the darker color? Let's move to this diagram. Fuel oil, because it has the highest boiling point. More number of carbon, darker the color. So it would be fuel oil. Identify which of these fraction has the highest boiling point. Fuel oil. Okay, next one. Identify which. Okay, this one is fuel oil. Sorry, I wasn't writing. Let me write. Last one. Identify which of these fraction contain the molecule with the lowest carbon number. Gasoline. Cracking involve heating some of the fractions to about 650 degrees Celsius. Name a catalyst. Oh, I didn't tell you the name of catalyst. What is the catalyst that we use in this one? It's usually aluminum oxide or silicon dioxide. Okay, Al2O3 or SiO2. So it can be silica or it can be alumina, Al2O3. One reaction that occur in cracking is C16H34 is converted into C8 plus H18. So what would be other product? C8H. How many hydrogen are left? 16. So just do the complete the subtraction and you'll get your answer. Okay? Is it 16? Yes. Complete the equation. And two molecule of alkene. Oh, sorry, I missed it. There are two molecules. So what would be structure of two molecules? C4H8, right? So there would be two C4H8. This won't be answer. Let me erase it because I didn't read the statement. Okay. The next part of this question is give three reasons why cracking is done. Let me copy first. What is the purpose of cracking? Okay, sometimes we add the anti-knocking agents as well to improve the quality? That is another general knowledge question. It's not related to you. Wait, why it's not moving? We are not going to discuss polymerization for now. Okay, why is cracking done? Number one, to convert longer chains into smaller chains. Okay. Then there was one demand and supply. The demand is high, so we need to convert into smaller chains so that more product would be formed. The third thing is, which we didn't discuss it, that alkenes can be converted into polymers. This is another topic, polymerization. When we discuss the alkenes, we would discuss this reaction, the polymerization. Since I've told you what is the role of double bond, how can be double bond converted into single bond? I've told you in halogens, right? So similar reaction would happen in polymerization. So the double bond would be converted to single bond and they would make long chains. That is polymerization. We'll discuss it later, but I'm just giving you an overview what is polymerization. Okay, so what are the three reasons? Number one, to convert the bigger chains into smaller chains. Number two, to meet the high demand. Number three, the alkenes are used to make different polymers. Have you ever heard of the name polythene? Polythene bags, the shopping bags, polythene bags. So that is basically ethene that has a longer chain. It's a polymer of ethene, polythene bags. Okay. So as a general example. Okay. Why it is important to remove sulfur from the fuel? Okay, it would form sulfur dioxide. So sulfur dioxide can be a pollutant for environment, right? Okay. One one of the major like causes of our respiratory disorders or the problems are these oxides of nitrogen, oxides of sulfur that are released by the burning of fossil fuel. Okay. First thing, it can cause the health problem. Second thing, which I was going to tell you now, I was about to tell you, that they can contribute to acid rain. What is acid rain? Let's discuss acid rain in detail. Acid rain is basically when these oxide reacts with water, they form an acid. Okay, the sulfuric acid or the sulfuric acid or the nitric acid. So these become part of our rain. This is quite common in the industrial areas where there is a lot of fuel burning. Okay, so the rain is known as acid rain. It has a very low pH and it can destroy crops, it can destroy buildings, it can destroy the buildings of what do we call it, calcium carbonate. Have you heard of the stone cancer of Taj Mahal, Agra? No. So it's one of these seven wonders of the world. Taj Mahal is in India, Agra. So currently, because India is quite industrial and using a lot of fossil fuel, so results in a lot of acid rain. Due to acid rain, the quality of marble is, or the marble is deteriorating, it's breaking, it's decomposing. So the scientists, they studied and they call it stone cancer, basically due to the acid rain. Okay, and it can acid rain can also cause serious health issues, uh, skin diseases, because when they directly fall on the skin, being acidic, it can be corrosive, right? Similar, if they fall on the plants, they are going to, exactly. So there won't be vegetation. The pH of soil change even, because it's acidic. It can change the pH of soil, and the crops cannot grow because they need specific pH. Okay, so this is all for today. We'll discuss alkenes and alkynes in detail on Thursday, and maybe we'll discuss alcohols as well. Okay, I hope you understand this all.